Howdy folks, Mr. Reed here, and welcome to One More Question. So what I want to take a look at right now is combinations of transformations, so specifically translations, stretches, reflections, kind of all together. We're going to do this one at a medium level, so I'm going to assume you kind of know what's going on with transformations from the get-go. So if that's what you want to see, well, let's get to it. Alright, so what we're going to do is just describe with words what's going on in the transformation that I have up above. So that one is g of x is equal to 5 onto f, bracket, negative 1/2 x minus 2, bracket, minus 3. So one of the important things to note is when you're kind of learning all this stuff, you kind of settle in on what you're going to call like your generic or general transformational form. So for the videos that I've been doing, what I've used is g of x is equal to a times f onto b onto x minus h, close off your brackets, plus k. So that particular notation, I guess, or that arrangement of parameters and functions is going to cause a to represent your vertical stretch, and if it's negative, a reflection on the vertical, a vertical reflection or a reflection about the x-axis. If the b value, the next parameter, that's going to control the horizontal stretch, and if it's negative, it is going to also have a horizontal reflection in there. But it's not b value is the horizontal stretch. It controls it, but it's actually the reciprocal of the horizontal stretch. So if you want to know the stretch, it's actually 1 over whatever the b value is. The h value is going to represent our horizontal translation, and a positive h will be to the right, a negative h will be to the left. Since there's a negative built into the argument, so it's x minus h, it kind of looks like it's doing the opposite thing to what you might visually see, but the h parameter itself, positive right, negative left, and that kind of clicks with what we probably would want. The k parameter is the leftover, it is the vertical translation. Positive is up, negative is down, so that again kind of matches up with the idea of what we usually use for left, right, up, down, positive, and negatives. So that's good. So what we're going to do is line up the actual expression that I have above me, which is g of x is equal to 5 onto f, and then minus 1/2 x minus 2 minus 3. So this looks quite a bit like the general layout that I've written above. However, there is a difference, and that is that the b value specifically, so this thing right here, is only multiplying the x and not a bracket that includes the x and the h parameter in it. That means that things are not situated quite the same way. And if I just take it as is and try to read off my a, b, h, and k, I might make a mistake in interpreting specifically what the h value is. So I'm going to take a moment and actually just factor out that 1/2 and move it outside of a bracket that includes the x minus h part. So the negative 1/2 there comes out to the front, and so dividing the negative 2 by negative 1/2 is going to give me plus 4. And so if I'm a little bit unsure of that, I could multiply it back through. We get the negative 1/2 times x is negative 1/2 x. The negative 1/2 times positive 4 is going to give me negative 2. That's what I have before, so that's good. All right, now from this point, we do have that everything that's here matches up with the parameters that we kind of described when we started things off today. So the a value here is a 5. The b value is a negative 1/2. The h value is actually negative 4, because we usually see it as x minus h, but this one would be minus negative 4 in order to have that same formatting. The k value is negative 3, and so from here I can actually just read off what all the transformations are. We have a vertical stretch, and I'm just going to use abbreviations because I'm lazy, I guess. So a vertical stretch by a factor of 5. Next up, we're going to move over to the b value. So this is a horizontal reflection. So I'm just going to call it HR. But it also is a horizontal stretch separately by a factor of 2 because it's 1 over the b value. So it would be 1 over 1/2. Dividing by a fraction, same thing as multiplying by the reciprocal. So that'd be like 1 times 2 over 1, which would give us 2. So horizontal stretch by a factor of 2. Moving to the next one, the h value, that's going to be a translation of 4 units left. So I'll write that out. Translation of 4 units left. And last, we have the k value is going to be another translation, and that one's negative. So that means we're going to be going down. So translation of 3 units down. All right, so that's the word description that goes along with this particular transformation. So that is the description of the g of x function in comparison to the original f of x function. This is done generally. We have no clue what the actual f of x function is. No problem, because g of x is just these transformations changed from that original f of x function. So hopefully you found that helpful. That's going from an original algebraic layout to a word description. What I'm going to do next is I'm going to take a graph-to-graph picture and try to write a transformation for it. So if you want to see that one, click on the next video. For this one, like, subscribe, and as always, take care, folks.